Okay. So I'm going to definitely need you to know the area of a rectangle. So the area formulas you need to know for like a rectangle, triangle, parallelogram. So therefore, a square and a rhombus. I'd say those are the ones. Oh, and a circle. Those are the ones I'm going to expect you to know. You guys all with me? You should know most of these from before. Parallelogram. Does anyone remember the area of a parallelogram? So if I give you a parallelogram and tell you how long the base is and what the actual height is, not the slant height, but the actual height, what's its area? Based on exactly. So a rectangle is just a special parallelogram, all that its side is actually its true height. Why is the side of a parallelogram not its true height? Yeah, because it's slanted. Yeah. So its true height is perpendicular to its base. I really want you guys with me. Do you all agree? Because you all operate at a rather high level on the highly scored. That a rectangle is a special type of parallelogram, yes? It has a side that is 90 degrees to its base, so it is perpendicular, so therefore its side is its actual height. Kick ass. So if I said how far off the ground is the Tower of Pisa, it would not be its like physical length, it would be the height from the ground to it perpendicular, yes? How many times can I hit myself in the head? Okay. You guys all with me? So there is an idea that's going to come up later today called slant height, or it's sometimes called slant length. So it's the actual length of the slant itself. Okay. How you guys feel about this? Do you guys think that's fair? So, by the way, it doesn't matter. No, it doesn't. If you had an actual good argument as to why any of this is not fair for me to expect, then you could give it to me. So if I ask you for the area of a kite, I will give you the formula. Yes, because that's definitely one of the more obscure ones that you probably, possibly, potentially never actually learned. Just depends. Now, real quick. If the area of a parallelogram is base times height, what is the area of a rhombus? Base times height, because a rhombus is a parallelogram. Isn't a rhombus also a kite? So there are two ways to figure out the area of a rhombus, and to be really honest, there's a ton of ways to figure out the area of anything. And we saw that last time. Do you remember we came up with the area formula for a trapezoid, yes? And you're all like, come on, man, don't ask me if I remember something, dude. But I'm going to ask anyway. Does anyone remember how we proved the area formula for a trapezoid? Does anyone remember how we did it? Because I don't. Huh? Oh, we could. So that tells me that there's kind of two bases to this. But I did something we do very often. I chopped it up. And how exactly did I chop it up? I made two triangles, yes. And then each of those I knew the area formula for. So if I'm given a shape that I don't know the area formula for, like a circle, for example, and I showed you guys at least once, if not twice, the idea of how to get the area of a circle. You chop it up into parts you know the areas of, add all those up, and then you get the actual area of the circle. Right? In that case, we actually slid them together and make this one big rectangle. I love you guys. Does anyone remember what the area formula for a trapezoid is? Yeah. Yeah. So it's the poor little trapezoid. was on a good season of the Game of Thrones. He got his head cut off, right? He's trying to be a triangle, but he's got two bases instead of one. So the area of a triangle is 1/2 base in height, so the area of a trapezoid is 1/2 both bases added times the height. It's basically the same formula because it's trying to be a triangle for a little dude. That's the way I kind of look at it. Right? Okay. So any questions about these expectations here? Okay. The only one of these that I need a formula for the perimeter is what? Which one? Circle. Because in general, the perimeter of any polygon is what? What's the perimeter of every polygon in existence? Add up all the sides, right? That is the only formula you need. So why then does the circle not follow that rule? Because the circle is not a polygon. Circle's not a polygon. Why is the circle not a polygon? Not made of line segments. Polygons are made of line segments. Polyhedra or polygons stuck together. So when we get to volume, there could be some differences there. We'll see. Okay. Look, guys. So that wasn't truly a little review, but sort of was a review. And I just want to tell you this because, well, not really because, to be honest, because I'm not going to have it on there. But we are going to have a quiz this Thursday on sorry. Some of you guys look at me like Wednesday. That would be really evil if I did Thursday.
Yeah. No, actually don't do Thursday.
If you miss it, you get a 0. Alright, so quiz this Wednesday. I think, was it last semester I taught Tuesday, Thursday, the 125? Yes, okay, that's why. I never know what day it is in here. So quiz this Wednesday on, remember the last test went up to 12.5, so this will be 12.6, 13.1. If I make it, all right, I'll tell you this. How about this? If I instead make it the following Monday, I'll add one section onto what's on it. Okay, sure. Okay. Monday. So a week from today, 12.6 through 13.2. So that will include area stuff. So on that quiz, I will put like area of a kite formula, all that kind of stuff. You with me? Yes?
Will that go on the paper?
Hell yeah.
And then we still test 12.6 to 34 on the
16th, I think.
23rd.
23rd? Okay, that's right. 16th is the last day we're lecture hours. Okay.
And then so we'll still test 12.6 to
12.6 to 13.4, yeah. Yep. I like it. Okay. Any questions about that? Look at that. We have like a democracy here or something. It's crazy. Every now and again, I relinquish some of my power. Okay. So, what are we talking about today? No freaking idea. Oh yeah. So before we get into volume, which is 13.4, we have one idea left to talk about. That's related to 13.2. So if I have a two-dimensional shape, I can ask you what its, now this would be really mean if I asked you what the area is. The perimeter would be easier. I could ask you the area and you could kind of chop it up, yes? Yeah. If I create a three-dimensional object, it doesn't make any sense for me to just say area. I have to be more specific then. So, because it could mean cross-sectional area. You guys with me? What's a cross-sectional area? If I have a cylinder, yeah, it's like a plane chopping through some 3D objects. If I have a cylinder and I cross-section it, it's going to make a circle, yes? So when I have a three-dimensional object, I need to be more specific about what area I mean. So the area we're gonna focus on in section 13.3 is surface area. Did everybody bring their kits by any chance? Some of you guys did. I have a few. Can everybody here, let's do it this way. If you have your kit, can you construct any three-dimensional object you want? Huh? Not very. Oh, I see what you mean. I mean from the whatever you want that you could make from your pieces. Go ahead and construct a three-dimensional object for me as I stand in here and look at you. Maybe I should make one. Let's see. Do I have anything with enough parts left? Arg. The last piece is always the trickiest. No, you don't. Ha. Do-do-do-do. Sorry. I'm gonna get that. No. So let's see, what shapes have you guys made? I made this shape. What shape is this? Not a prism. Right? Why is it not a prism?
It's not flat on both sides.
Yeah, it's got to be a shape that's repeated along a length. That's the quickest way to remember it. Like a Toblerone would be a triangle repeated. You guys know what a Toblerone is? The candy bar? Triangular in shape? Tint, a very basic tint. If you drew a tint on your picture, most of you guys would draw a triangle and extend it. That would be a prism. It's a repeated shape. If I took a cross section anywhere, it'd be the same shape. So this is not a prism, it's a pyramid, yes? Triangular based pyramid, you can even call it an isosceles pyramid, you can call it tons of stuff. Who else has made a different shape? Oh, you made a smaller, alright, so I got a little brother of this guy, I like it. Or it could be the older one.
Just had a taller head.
Yeah. Anybody else make a different, ooh, sorry. Rectangular solid. Poor little guy got such a pathetic name, but this is also a what? Prism. Because it's a repeated shape. That shape is repeated along this length. I like it. Maybe you've got the same kind of thing there. I like it. Like a little puff tent. You got a puff tent going on. Yes, and that of course would be a prism. A big old fat going on. You got one like me. No, one like this.
I'm just missing a piece.
Oh, shoot. I understand. Okay. Oh, there we go. Sorry. There we go. I like that. Cool. Some of you guys have made this one before. Yes. What's the shape of the base? Hexagon. I love it. So this would be a hexagonal prism. Okay. If you wanted to figure out the surface area of your shape, how would you do it? And I didn't even define surface area, but does it make sense? How many surfaces does my shape have? 1, 2, 3, 4. So what do you think surface area means? Yeah, I gotta do my math voice.
That's the area of the surfaces. We'll call it surface area.
Yeah, so if I just take the area of all of my surfaces and add them together, I get the surface area. You guys with me? Okay, so your various shapes, if you busted out a ruler, you can get the dimensions and you could figure out the surface area. So yours, for example, she's got rectangles connecting the sides, which makes sense. So any kind of like regular polygon prism is most often going to have a rectangle along the sides to connect the two sides of each one of the faces. You guys kind of with me? So you got rectangle sides, and then you got the hexagonal. Now this, the area of a hexagon. Can you imagine? That might be a little involved. Yeah? Okay. So if I want to know the surface area, I could just measure the appropriate dimensions of each face and add them all together. All the perimeters, add them up. All the areas, add them up. You guys kind of with me? So surface area is kind of like the 3D analog of perimeter, which is what I was thinking right there. Okay, so let's formalize some of this stuff. Ooh. Let's start off with the easiest shape. Obviously, it's pretty good. That's a stick of butter that's kind of melting, so leave them alone. If I want to know, have you ever seen the? No, let's do this. I don't want to designate these. So we'll call this height. We'll call this, base. We'll call this length. What would the surface area of this be? Well, first off, let me ask you this. What do you think lateral faces means? Let me make sure that's what they actually use here. Lateral faces. Forget which term they use. Nope. Okay. I'm looking to find it. That'll work. Lateral faces. What do you guys think? What's lateral mean? If anybody works out your lats, sides. I like it. So the lateral faces, there's like 4 of them. You with me? And if I stood this up, there's 2 bases. That's the top and the bottom. So the lateral sides, the lateral faces are the faces on each side. That's the sides connecting the repeated shape in this case. On mine, it's kind of hard to designate the lateral sides. Yes? But for a prism, the lateral sides are what's connecting the common shapes. I like it. So the surface area, there's 4 lateral sides, yes? And then there's a top and a bottom. So what is the area of the top and the bottom in this case? What's the area of the top, the side facing me? Base and side. Kick ass. And there's 2 of those, right?
Yeah.
So there'll be 2 base heights. And then there's 4 sides that have what dimensions? Length and height. So there's 4 length times heights. I don't think this book. Oh, that's weird. Do they do that? They don't even talk about it. It's weird. Okay. All right, we're good. No, okay. I like what they do. All right. Let's extend this idea. This is one of the most basic prisms I can make. So let's talk about general prisms. So it's relatively easy to draw a prism because you just pick a shape and then you kind of do the vanishing point technique, sort of. So if I want to make a prism with a triangular shape, I just do this kind of a thing, and I could even try to designate the other sides I can't see. Ooh, that's really good for me. Now, what would the area of this prism be? And let me give you some information. I'll say the area of a repeated shape. We'll call it A. And let me see if you guys are cool with this. Let's work this out. What would you need to know to figure out the area of this rectangle here? Who made the shape like this? Oh, maybe can I borrow yours? All right. So I've got this little dude, yes? So what would I need to know to figure out the area of the rectangle? What would I need to know? Well, I need to know how long it is, yes? What else would I need to know that's related to another part of it? So this rectangle right there, this rectangle. The length of the prism is one thing I need to know, yes? What's this? You can do it. This is related to the triangle, yes? So this is related to the perimeter of this guy. Because don't I have a rectangle connected to every edge of this triangle at the bottom? Yes? I really want this to be with me. So whatever shape this is kind of cool. No matter what shape this is. In fact, let me borrow yours real quick. Do you all agree with me? What's the perimeter of this dude? What would you do to figure out the perimeter of this guy? Add the sides, yes? Yes? This side determines the base of that rectangle, yes? So, whatever the perimeter of this is, if, I really want you with me, this times the height would be the area of this rectangle, yes? This times the height would be the area of this rectangle, yes? No matter if the bottom is irregularly shaped, not a regular polygon, you would take every element of its perimeter, multiply the height to get that rectangle that's connecting, yes? So if you just take the perimeter, the total perimeter times the height, you'll do all of that at once. I'll have to do this piece times the height plus this piece times the height, yes? Let me try to do it this way. So even if my triangle was scalene, let's say I had a scalene triangle here. If I took, I'll say side 1, side 2, side 3, let me use the same notation the book does, yeah, all right, good. We're gonna call this a height. Poor little dude, somebody laid him down. If I take side 1 times the height, that's gonna be the area of the back rectangle, is that cool? Side 1 times the height is the area of this back rectangle, yes? Side 2 times the height is the area of this, where is it at? Which side? There it is. This front rectangle. And side 3 times the height is the area of in this case, the base rectangle, yes? Are y'all with me? What's common to everything I just wrote down? And by the way, is that the surface area of the prism yet? Let me start there. Is what I've written the surface area of the prism? What have I left out? The sides, and then we can add that in really easy. Let me just focus on just the lateral faces for right now, yes? What part of those is common to each? H, so I can factor an H out, yes? And by the way, this works no matter what shape this is, correct? So I can have more crap here depending on how many sides the shape was that I constructed the base out of, yes? If I take an H out, and this could potentially go on, what is this? If I add up all the sides of my base shape, it's the perimeter of the base shape. So if I'm given the area of the repeated shape and the perimeter of the repeated shape, and the height. Okay, let me stop for a minute. So they tell me the area of the repeated shape, the perimeter of the repeated shape, and the height of my prism. And if you lay it down like it is, you can call it the length, but we're just going to call it height in general. Then the surface area of that would just be, how many of these do I have? I've got 2 of these. So 2 of these plus what we just figured out down here, pH. That I'm almost certain is a formula you've never seen. What kind of prism does that work for? Every prism. That is a powerful formula. Now, real quick. That formula I've written works for every prism. Yay. What part of the formula drastically changes given different shapes? Definitely this guy, yes? What does this guy represent again? Area of the repeated shape, yes? So for Laura, it was a hexagon. For Peyton, it was a triangle, yes? I could use whatever the freaking shape, I could use the freakiest looking shape ever and just connect all the sides with the same shape on the other side. I've made a prism. All a prism is a shape that's repeated. Remember, I don't know if you guys remember this. The book specifically says a prism has to be made out of polygons. I disagree, because that formula we just wrote works for cylinders also. Is a cylinder officially by the book a polyhedron? Is it a prism? Not by the book. It's going to be okay. So there are always, every book I use, I disagree with parts of it. You can go, you're wrong, Jeff. And I'm like, okay, that's fine. All right. How do you guys feel so far? If I gave you a problem like this, I would have to either give you the area of the shape or give you everything you need to determine the area of the shape, yes? So, let's try a problem. Let's try a problem. So what if I have a triangle where the base is 6 and the height is 7, and holy crap, that's not quite right. Leave me alone. It was windy when I set up my tent, okay? And that's repeated all the way down, and this is 14. And we'll say this is feet. Feet. So if I want to use the formula directly, I'm going to do this 2 ways. What do I need to figure out first? Or what's something I could figure out that I need for the formula? What's the first thing I hit in the formula that I need? A, what's A? Area of the repeated shape, yes? Can you guys take a moment and figure out what A is? Don't say anything. Just figure out what big ass A is. What is that? Don't say anything. All right, so who's got, what's the area of the base, area of the repeated shape, sorry?
21.
Yeah, so you take half, 7 times 6, you get 21. 21 what? Good, square feet. So length is in feet, for example, area is in square feet, volume is in cubic feet. It's all about, area is all about covering a surface, volume is all about filling a shape. How do I get P? What have I not told you that you need to get P? Oh, this is kind of gross. I didn't want to make this was gross, but let me make this. This isn't going to quite be an actual thing, because the actual thing would be 49 plus 9 square root of 58. So let's say let's make these sides 8, just to make it kind of nice. Okay. So if anybody's curious about what the hell I just said, I didn't give you those, correct? And I should have waited for a minute after what I just asked you. How do you figure out P? Well, what is big P? Big Papa. It's the perimeter of the repeated shape, yes? And I didn't give you these. Okay, I like it. And it's definitely not equilateral, because there's no way this could be 7. Okay, maybe. Not sure if you guys really care too much, but real quick, this right triangle here, how long is this? 3. 7 squared plus 3 squared is 49 plus 9 is 58. That would have to be square root of 58, but I'm going to make it 8 just for now. You guys kind of with me? All right. So this only exists in Jeff's mathematical imagination. Okay. But let's do this. What is the perimeter that I need for that? What's P? Yeah, 22 feet. Good. Okay. And what's H, of course? 14. Good. Now, so if I want to feed this formula what it wants, I have to figure out the area of the repeated shape, the perimeter of the repeated shape, and how long that shape is repeated. The height, in that case. I like it. And now I just throw stuff in, right? I just throw stuff in. So let's see. Twice the area plus 22 times 14. Let's see. 14. Plus 350? Probably not. Let's see. Maybe it is. Is it 350? Yes, okay. 350 what? 350 what? What was this, by the way? What was this? This is 21 what? Square feet. This was 22 feet. This was 14 feet. So this is all feet squared. So of course this is square feet because it's an area, yes? It's the surface area. So it's got to be square units. So if I ask you for a volume, you know you better end up with cubed units. If I ask you for an area of any stripe, you better end up with square units, yes? Okay. Can anyone see? Now I'm a little concerned because I kind of made this shit up on the way. I should have been more careful with the numbers I chose. Can anyone see another way to figure out the surface area? More directly without using this? What's the area of this rectangle here? This rectangle on this 8 times 14, yes? And the area on the other side is 8 times 14. The area on the base is, what's the area of the base rectangle? It's not the same, is it? 6 times 14, yes? I'm really curious if this will actually work. Now I made some triangle that doesn't exist. Crap. No, it probably won't work actually, now that I think about it. I'd have to make this side square root of 58, which would be gross. But, if you had an actual shape that existed in reality, you would have two ways to do it. Mathematically, they're both the same. Let me see, I really want you guys with me here. The 2a plus pH is a general formula that will work no matter what. In any specific situation, there are quicker ways to get the surface area, or at least to think about it. They equate to this mathematically. I don't know if you guys are with me. You guys see what I'm saying? That formula kind of takes you away from the geometry of it, and you're just thinking about how to plug shit in. But if you just think, okay, that's a rectangle, I can get its area. That's the same rectangle, I can get its area. The base, I can get its area. I can get the area of the triangles, and I can add all that shit up, yes? That's more just looking at the shape you got and working out the areas of each side. I need you to understand this. So do you have to use 2a plus pH? Only if I say you have to, yes? Otherwise, whatever shape I give you, you can work with it. So if you understand what surface area means, there's almost always more than one way to get it, yes? So this formula is an attempt, and by the way, real quick, just to remind you guys, what does that work for? That formula specifically works for prisms. I love it. Okay. So that's one of the first big formulas we learned, and it's kind of like, to me, it's kind of like you could, all right, does anyone know the perimeter formula for a rectangle? I think I asked you this before and nobody did, which is interesting to me. 2w plus 2l, have you guys ever heard of that? Do you need to memorize that formula? So this is kind of like the same level. Any shape they give me, I don't have to know its perimeter formula. I could just actually just add up all the sides. Any shape they give me, I don't necessarily have to know its surface area formula. I can just add up all the sides areas. You guys with me? Why does that make sense? Because surface area is the 3D analog to perimeter. Okay, maybe. Okay. Sorry. So let's talk about something I brought up earlier. Cylinders. The quicker I do it, the better it looks. Although that's horrific, for me, that's stellar. You know, somehow the back side of it exists where it doesn't exist. It's okay. It's got a cowler too, but we'll be all right. So that's a cylinder. What's the repeated shape? What's the repeated shape? Circle. So I got to tell you its radius, and I have to tell you the height. Now, can everybody please, does everybody have a piece of paper that you can hold on its own? It doesn't matter if we're not going to do much with this. We're not going to chop it up. It could be something, it could be your notes or whatever. I just need you to fold it for a second. You're not going to fold it like really back. You need to understand. Whatever you're going to, whatever's on this paper will be okay. That's what I'm trying to tell you. So here, I'm going to take this paper that I need because it's where I've done my notes. Yes? Can you construct a open face, open bottom cylinder out of your paper? And try to do this. Try to make it so that the ends meet. See what I mean? All right. So everybody made roughly this? Some of you guys are still scrambling for paper. I was waiting for somebody to do this. There you go. Jeff being a little jackass. All right, I made my cylinder. Oh, there we go. Something like that. Or you can do this. Okay. You guys kind of with me? So, what you are holding out, now real quick, the top and the bottom of the surface. That shit we know. What is the surface area of this? Why is that not a problem? I need you to really understand. You guys, if I had a cylinder and I want to know its surface area, yes? In fact, if I have any freaking three-dimensional object in the universe and I want to know its surface area, don't I just add up the area of all the various sides? Now, a cylinder, again, doesn't really have a side here, but it does have a surface. So I need to add this surface to these circles, yes? Circles are easy as shit. What's the area of a circle? It's the area of a circle. Now, in reality, pies are normally round, but for us, pi are square. Right? For a circle area. You with me? So then the question is, what's the area of this frickin' side? But that's silly, because it's just the freaking rectangle, yes? You guys with me? I need you with me. Okay. Does everybody understand? This is a cylinder, for damn sure, yes? This is a cylinder, open top, open bottom. We're okay with that. So it's like a pipe. We do. If I just look at a cylinder and I say, what is the surface area of this? You're like, I don't freaking know. How the shit would I know that, Jeff? But if you just open the damn thing, it's a stupid rectangle, correct? Now, help me out, guys. What is the circumference of the circle? What's the circumference of the circle? 2 pi r. Okay, guys. So what is the length of the rectangle? 2 pi r, yes? And this would be h. So what is the area of the rectangle? Let me draw it. So this is my paper. This is my little seam where I put them together. If I just open that up, this would be the circumference, yes, because that's where the hell it came from. This would be the height, because that's where the hell that came from, yes? Don't give me shit about them not being the same. Sorry. Now I can't unsee it. Okay. Jeff, okay. There, height. Is that better? Yes, Jeff, that's a little better. Okay, that's a little better. And this would be 2 pi r, yes? So the areas of these circles, each one is pi r squared, and I have 2 of them. Holy shit. And what is so that's the surface area of the top and bottom. And what's the surface area of the outside? What's the surface area of the lateral side? There's only one side, which is neat, but 2 pi r h. So the total surface area would be 2 pi r squared plus 2 pi r h, which I think the book, it doesn't really matter. Where did you put it, book? Oh yeah, they did. It doesn't matter. This is the one I know. Do you guys agree that both of these expressions have a 2 and a pi and at least 1 r? So I could take a 2 pi r out, and then I'd have r plus h left. 1 extra r, and then an h. Is that decent? You'll see this formula if you look in the book, but the first formula is what I know because it makes most immediate sense. 2 pi r squared are the 2 circles. 2 pi r h is the rectangular side. Are you guys all with me? Yes?
Second one, was it plus or t?
Oh! My r and my plus got together. Yeah, my t's will look like that. Yeah, sorry. Trust me, the more math you do, the more you realize t's suck. So you gotta make them look different. Yeah. So how you guys doing? Okay. So I need you to understand, just like perimeter, I don't need to know, I really don't need to know perimeter formulas because they just add up all the sides. This one is a little harder, but it's the same idea. I don't really need to memorize the surface area of a cylinder as long as I know the area formulas for all of the sides. But that's what this formula does, it just puts that together. If I just add up all the areas of all my faces, all my sides, I'll get the total surface area. Now, real quick, I want to show you something. What was the formula for a prism? Where P was the perimeter, yes? What is the perimeter of a circle? Oh my God. If I try to look at you with glasses, it really doesn't do me good. What's the perimeter of a circle? 2 pi r, yes? And look at the second part. This is another reason why I don't like that. In fact, screw this. Look right here. Isn't this pH right there? Isn't that pH? Not, like acidic and base, but. And what's the area of the repeated shape? Pi r squared. Isn't that what that is? Pi r squared. It's 2 of them, yes? So, this is why You'll talk to any mathematician, and they will say a cylinder is a type of prism. Not just because it follows the surface area formula, but because this idea of a prism is a repeated shape. Okay, so that's one big place I disagree with the book, because I think they made it a big deal about a prism can't do that, but screw it, that's not true. Okay. You guys somewhere with me? All right. Moving on. Oh, by the way, I'm not going to prove this, but I just want to show you this. The area of a hexagon for like Laura's shape, the area of a hexagon is 3 rad 3 over 2 times a squared, where a is the length of a side. Now, real quick, I just put that down there so you know it exists. You don't have to memorize this. You don't have to use it. I don't think the book even talks about it, if I remember correctly. No. Those people. Would you say that that formula is obvious? So if I knew the length of a side of my hexagon, it's got to be a regular hexagon, I should say, right? Then it would all have the same side lengths, yes? Then that would be the area of it. You all agree that that is not obvious, right? Okay. A squared makes sense because then it would end up with square units. But where the shit did 3 rad 3 over 2 come from? Well, it came from a lot of weird ass math. Okay. A lot. Some of you guys might notice, I don't know, has anyone ever taken any trigonometry? Does that kind of feel familiar in terms of the numbers in there, in terms of trigonometry?
Yeah.
Rad 3 over 2? Yes?
Sadly, yeah.
Okay. So it might have something to do with triangles, breaking things down. Okay. We're not going to get into it, I'm sorry. I just want you to know it exists. Every polygon, especially regular polygons, I should say, has an official area formula. Sorry I did that. I'll move it. Go away. Free people. So what about a pyramid? So we make a very simple pyramid. Holy crap, John. Alright, well that was bad. That was bad. Okay. We'll be okay. So if I tell you the area of the base is A, if I tell you P is the perimeter of the base, and here's where something comes into play that hasn't come into play yet. Do you all agree there's an actual height of this pyramid? There's also a slant height. Or I think does the book call it? Oh good, okay, the book I think calls it slant height instead of slant length. Slant length is just weird. So the slant's length is L. Then the surface area is going to be the area of the base. And let me see this makes sense. Any pyramid you create, what will its lateral faces have to be? What will the side faces have to be? Any pyramid you create? They have to be triangles, yes? You guys with me? Okay. And what's the area of a triangle? 1/2 base times height. Yes? Now, real quick. How do I say this? Well, okay. I'm not going to get too deep into this, I don't think. So what we end up with here is 1/2 the perimeter, because I'm going to do this to make this triangle, this to make this triangle, this to make this triangle, this to make this triangle. Just like we did with the prism earlier. Every edge of the perimeter gets its own little formula, so if I add them all up, it ends up with a full perimeter. And then weirdly enough, it's just times the slant height. And this, to be really, really specific, this is for a right regular pyramid. Because otherwise, L wouldn't have to be the same. In fact, from my horrible picture, it looks like this side is shorter than that side. But a right regular pyramid, which means the height, if I dropped it down from the point at the top, it should make a 90-degree angle with the base. Well, it would for any case, but it has to be equal length stemming off from that. Not sure if you guys are with me or not. So just to kind of show you what that word right is really doing here. This is a right, holy shit, Jeff. Yeah. This is a right circular cylinder. This is not a right circular cylinder. Can you see where the idea of right comes in? The first one obviously has more of a right angle idea to it, whereas the other one does not. Its slant length is definitely slant. It doesn't make a 90-degree angle with the bottom. Okay, so that's roughly what it means. The pyramid, let me see if you guys are cool with this. Here. Everybody do this with me. You guys ready? And obviously, looking at my artistic ability, no need to critique yourself too much. And if you're a really good artist, that's good for you. So, that's not too bad. So everybody can make a little rectangle, yes? A little rectangular solid, yes? And in fact, you could even draw in the little sides and make it look all nifty. Okay. I can make a pyramid out of this by, let's pick a point in the middle of the top surface, yes? And then just connect every corner of the base, connect it to that point. Oh, crap and a half. Make the point big. All right, again, me and pyramids. You guys all see what I'm saying? I can construct a pyramid from another three-dimensional object by just shaving the sides off. Yes? You guys kind of with me? So you can think of some old guy whittling some wood down. I made a pyramid, right? If my original shape had been skewed somehow, then I would have ended up with a non-right pyramid. You guys kind of with me? Maybe? No? Screw you, Jeff? Okay. And by the way, we're about to talk about this anyway, I believe. Yes. If I took a cylinder, I'm going to do the exact same thing we just did with the rectangular solid. I'm going to do the exact same thing with the cylinder. Pick a point on the top surface that's in the middle. So draw in the point in the middle of the top surface, in the middle of the top circle, yes? Right there, keep that cool. Now this next instruction is going to be weird. Just like we did the first one, connect every corner of the base to that circle. Why is that a weird instruction?
Because those aren't big corners.
Yes, now you could instead, a circle has either no corners or infinite corners. Whatever, Jeff. So if I just take, like the side ones especially, but then also like the back one and the front one, that would be a cone. So a cone is a very simple pyramid. How do I construct a pyramid? Well, you make a prism. You with me? I made a very simple prism up there, yes? So how could you make a prism different from the one I made on the top picture? Peyton's got a prism. Hold your prism up, Peyton, if you would, please. Thank you, miss. She said, yeah, whatever, man. she made a different prism than me because her base is a triangle. So if you would have made a triangular base and connected all the corners, you would still make a pyramid, correct? Okay. So if I start with a cylinder, which I recognize as a prism, in fact most math people do, and I just follow the same instructions, that must mean that a cone is a type of pyramid. It is what I consider to be the most basic pyramid. Okay, I like it. I like it. Okay. So let's talk about the cone. This one's going to get a little tricky. So let me put some stuff in here. If you haven't drawn this for yourself, you want to draw it now. In fact, let me draw just the cone by itself. You can do this, Jeff. You can do it. Shoopa. Can you? Sort of. That's a big old bait. Look at that. Pretend like that's a right cone. Poor little guy. This again is the slant length. This is the height. And this is the radius. That's crazy. Can somebody tell me how does the length, the slant length, relate to the height and the radius? How does the slant length, what picture did I just draw when I drew in the height and the radius? What shape? Triangle. So if I take a cone and I chop it down the center to the bottom, that cross section would be a triangle. You guys all with me? Because the side is definitely straight. It's the bottom that's circular. But if I just took a triangle, Jeff, do it. I will. If I just took a triangle and rotate it, I've just constructed a cone. If I somehow had a way to make my rotation stay there, it would carve out a cone, yes? If I had a drill bit and I put it in and I would make a cone shape, cone depression. Okay. I like it. Kick ass. That's enough of that, Jeff. So what's the relationship then? What's the mathematical relationship between L, H, and R? We might have to use some old Greek cult leader to help us out, right? You're all like, no, just tell us, man. No, you tell me. It's a triangle, right? What's the relationship? Just tell me. H squared plus R squared equals L squared. Okay. So what is L then? What do I have to do to kill the square? Take a square root. Normally you have to put plus or minus, but of course this is a physical measurement, so it can't be negative. So the length is the square root of height squared plus r squared. Height squared plus radius squared. Is everybody decent with that idea? If I know the height of a cone and the radius of the cone, I can figure out the slant length of the cone. So obviously, if I try to create a problem for you on a quiz or a test, I have to be more careful than I was earlier in terms of that, because it has to meet the Pythagorean theorem to actually be a physical existing thing. Okay. I can't just pick any numbers I want to. Now, if I were to open this thing up, if I were to cut through the side, take the circle out of the bottom and open it up, this would look like, let me see if you guys are cool with this. This would look like this. Maybe not as big, but okay. Boy, more circular, Jeff. Oh well. It would look like a circle. You try this again. Take a circle, and you just chop out part of it. There we go. So now just copy that, Jeff. Oh God. Okay. If you wrap that around, in fact, next time I might have you guys do this. Can you imagine if you wrap that around, you make a cone? Because if you turn it in on itself, those two sides here will start to come together, yes? And then you can make a cone out of it, yes? So how did we investigate the surface area of shapes earlier? We created them, and then we could deconstruct them if we wanted to. Look at each surface by itself. That's kind of like what I'm doing here. One surface is this part of a circle. what is this? Let me remind you where things came from. What is this? No? Bless you. This will be L. Maybe. So if I took the base out, so this is the base with radius R. This is the part that goes into, if I fold it down on itself, it would go into making the cone. Sorry. No. Let me stop for a minute. So what is the area, of course, of this piece? What's the area of that top of the cone, right? What is that? What is that you can buy? Ice cream, nutty, buddy, what is it? You guys know what I'm talking about? No? Yeah, whatever, Jeff. Where you can take the top off and then, no? That's too bad for you guys. All right, we'll be okay. So it's a cone with a top to it, yes? You with me? So it's not like an ice cream cone, it's got a top to it. You're like, when you put the ice cream in, you're like, shit, it's all closed up, damn it. So this is the top of it. So this is pi r squared, of course. Now the question is, what the hell is the area of this piece? Because that would tell me the surface area of the cone, yes? I need to know the area of this piece. Well, that gets rather freaky. So let me just, do I want to, it's a little bit trippy. I'm just going to tell you, it's pi r L. So the surface area of this thing would be pi r squared plus pi r L. I can't remember the book. It does weird things to it again. Oh, I see, okay. So let me write it this other way also. Pi r squared plus pi r square root of h squared plus r squared. Because we figured out earlier that L is this. So you might see it like this in the book. This works also. If they give you the slant length, you could just throw that in there. If they don't, you have to calculate it, yes? So let's try one. So everybody got that business? Nope, sorry, good. I'll draw my little cone dude. Oh crap. Poor little dude. So I got a cone. I tell you the radius is 3 inches, and I tell you the height is 4 inches. Come back to me. Come back to me. Wait, what? So, do you guys all understand that mathematically these are the same? Because L is equal to this. So you can look at this 2 different ways. You can either just plug stuff into this guy. Because do I know everything I need for this? Yes, right? Or you can figure out what L was and sort of plug it into here, but I mean, either way, it's the exact same. It just depends on what you guys like to do. If you like to construct parts of your equation first and then throw them in. So go ahead, figure out what the surface area is of that cone. There we go. So it's 4 inches height, 3 inch radius. So I made this one's kind of nice. Try to find something real quick. Let's see. No. 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 All right, well, shit. Too bad for you, Jeff. Oh, here we go. Oh, you suck. No. Damn it. Sorry. I'll be okay. Oh, there we go. Ooh, yeah. That's a little more than I wanted. I'll be right back. Stop. Alright, let me catch up to you guys. So, if you just plug into this dude, of course here I'm going to put 3, and then 3 again, and then I could put in here square root of 4 squared plus 3 squared. Now what is the square root of 4 squared plus 3 squared? 5. So you got your 3, 4, 5 triangle. That's going to show up quite a bit on standardized tests. They really love 3, 4, 5, 5, 12, 13. Those standard kind of like Pythagorean triplets. Those guys that have no radicals in them, which is nice. There's not a lot of them compared to how many aren't that way. Sort of. So here I'm going to get 9 pi plus 3 times 5, 15 pi. So I get 24 pi. Is that cool? 24 pi what? Yeah, inches, square inches. I love it. And then you can approximate that by multiplying by using your pi button. Some of the homework might say use 3.14. I can't remember. I know I did on one of those handouts we talked about. Yes. 3.14 of course sucks as an approximation for pi, but it doesn't do too bad for little problems like this. Okay. So last thing I want to talk about today. So now we know this. This is, what does this work for? Cone. And by the way, if I gave you a cone and I told you, holy shit, I told you the height and the slant length, then you could just use this one directly, yes? I have to tell you the radius also, but, oh yeah, I don't have to tell you the height. Just have to tell you the radius, there we go, and the slant length, then you can use this one directly. So that might happen in the homework, just to let you know. Last thing I want to talk about, what about the surface area of a sphere? Now, that's rather complicated, yes? It's a little bit trippy, but there's a really cool thing. I wish I would have looked for this earlier. Let me see if they do what I want them to. Sort of, not really, sort of, not really. Sorry guys, hold on. Arg, they get way too deep into it, yeah, shoot. But if I take a sphere, diameter d, I'm telling you this is a sphere. Okay. So I really should do like that. Okay. And I compare it to a cylinder of the same height. Here we go. So how tall is this sphere, by the way? How tall is that sphere? That's a weird question, but it's kind of silly at the same time. D. It's D tall and D wide, yes? The diameter. So if I took a cylinder of the same height and the same diameter, they actually would have the same surface area, which is kind of trippy. So you can imagine, this is not easy to do. So obviously this piece of paper doesn't really work unless I fold it a little more than normal, because I need, do you guys see how this would be, it'd have to be the same diameter as it is tall. So this doesn't really work this way, it really doesn't work that way. You guys kind of with me? Okay. So the diameter has to be the same as the height is. So that's not gonna work, I'd have to like cut this, but if I kind of fold the top in and fold the bottom in, it could conform to the outside of that sphere. I did bring a picture that I thought might be okay. Yeah. So if you chop this away so you can kind of see in, so you can see the sphere, can you imagine, can't really see that, can you? I could fold everything in and it would kind of match perfectly up with the outside of that sphere. This was proposed quite a long time ago, and it was proven several times over. But if I do that then, okay, so what's the surface area of this cylinder then? So this diameter, of course, is 2r, so this would be r. The height, what's the height then in terms of radius? 2r. So what's the surface area of this cylinder? And that's minus the top and the bottom. So I want those open, yes? So I can fold it in. So the surface area of the side, see if you guys are cool with this. Do you remember how it was 2 pi RH? So this will be 2 pi r, and what's the height? 2r. So this will be 4 pi r squared. That is the surface area of a sphere. 4 pi r squared. Do you guys see that pathetic cross section I tried to draw into my sphere? You guys with me? And you're all like, yes, it's very pathetic, Jeff, thank you. What is the area of that circle that kind of has the diameter running, the diameter of the sphere? What's the area of this circle? That would just be pi r squared, right? So isn't this is kind of trippy. The surface area of a sphere is just 4 times the area of what we call a great circle. That's not just a nice circle. It's a great circle. So what I mean by that is, isn't this a circular piece of the sphere? It's not a great circle because it doesn't have the diameter of the sphere as its diameter. So I could have drawn a great circle this way, yes? This way? I could have done it several different ways. So somehow, the surface area of the sphere is 4 times the area of a great circle, which is nifty. And again, normally it's just me that feels that way, but that's okay. All right, I wanted to leave things off a little early today because I have a fantastic meeting at 11, which I just love. So next time I'm going to bring a little worksheet for us to work on over the stuff that we talked about today. So last time I'll talk less and I'll draw less. 2 very good things. And of course next Monday we have our quiz, 12, 6 through 13, 2, as you guys all hold it. Okay. All right, I'll see you guys. Welcome back. in the lowercase, but it's point two. So, you figured out what the distance is between PQ is gonna be little q minus little c. They ask you for the next part. This part, this part you're asking about? So, see, they ask you to figure out
I think it's so
PQ, so that would just be q minus p. But then they ask you to add it to, yes. Now, if you write 1/2 of parentheses, you take half of that length out of this. And then you add it to little t. There's some algebra you do, there's some distribution and putting together. So kind of since if I start at p, and they go halfway, well, if I figure out first how far it's halfway, and then I add it to p, figure out where that position is. Oh yeah. Find half PQ, so part B is gonna just be half Q minus P. And part A figured out what PQ was. And then actually, so if you just take 1/2 times Q minus P and add it to P. Distribute the 1/2. And then you can combine stuff. It kind of is silly, because what you're gonna get is exactly what you expect. If I wanna know the number between these two numbers, I can just take the average. And I would take the average of the numbers, add them up and divide by 2. You're gonna get that once you do that. It's just showing you algebraically what's another way to get this out. Cool. Okay. Thank you. Anytime, man.